Okay, welcome all of you. Now, in last lecture, we discussed about or started about the test performed on the fine sand or the fine aggregate. The first we see the procedure of the fineness modulus of the fine sand by sieve analysis in last lecture. So, in this lecture, we go for the second test, that is determination of the silt content in a sand, which is required uh, to know, or by this method or by this experiment we can know the quantity of the silt or percentage of the silt content in the sand, so that you can know the idea about using the sand, or if there is the silt content is greater than specific standards or the specific amount, then we have to apply some corrective measures to use the sand on a site. The apparatus requires are 250 ml measuring cylinder, a glass measuring cylinder of minimum 250 ml. Second is the water and sand and tray. Also, we required the salt for adding into the water. Test procedure. First, we have to fill the measuring cylinder with 1% of the solution of a salt and water up to 50 ml. The measuring cylinder which you used in first year for the chemistry lab, the same measuring cylinder of 250 ml like this. It is the 250 ml measuring cylinder. Okay. Firstly, we have to put the water in the measuring cylinder up to 50 ml with 1% of the salt. Add the 1% salt by the volume of the water. Mix the solution well, that is the water and the salt. After mixing the salt solution, then add the sand sample for which we have to determine the silt content. And add the sand into the measuring cylinder such that the level reaches up to 100 ml. That is, first 50 ml we add the water, then again add the sand such that water plus sand should be reaches up to 150 ml. After adding the sand and getting the level 100 ml, we add the extra solution, that is the solution of the water plus salt, into the measuring cylinder up to 150 ml. That is, after adding sand, we also add extra water such that it reaches the level up to 150 ml. Third step, cover the cylinder and shake it well. That is, cover at the top by hand or by any apparatus or the part on the top, and they shake the measuring cylinder such that the water and salt will be truly mixed or uniformly mixed. After uniformly mixing, place step number 4, that is, after mixing we have to place the measuring cylinder for 3 hours in a undisturbed condition. And next step, that is, after 3 hours the silt content settle down over the sand layer. That is, after putting the measuring cylinder undisturbed condition for 3 hours, the silt particle, due to the light weight, they come at the top or settle at the top of the sand, and the sand which is having the greater weight, they settle at the bottom of the silt. So after 3 hours, we can get the measuring cylinder like shown in the figure. That is, the top is the silt content, and bottom is content of the sand. Then note down the silt layer as a volume V1, that is the volume of the silt layer. This is the V1. Second, note down the sand volume, that is V2. The sand volume we can note down as a V2. Sand sample is given as a volume V2. Then repeat the same procedure two more times. That is, we have to take a reading, minimum 3 readings for the silt content for a single sample of the sand. And after getting the 3 readings, we make an average, and the average value represent the silt content in the sand. The permissible silt content in a sand percentage is only 5%. That is, the silt content allowed for any sand is up to 5%, that is maximum 5%. If the silt content is below 5%, we can use the sand as it is for the construction work. If it is increases beyond 5%, then we have to apply some remedial measures so that it can be useful on the site. After getting reading, we can calculate the silt content, that is V1 upon V2 into 100. Volume of a silt divided by volume of a sand sample into 100. This is the about silt content procedure. Next point is effect of silt content on a concrete. If silt content is exceed beyond the 5% or given limit, then it have effect on the concrete properties, such that point number first, increase in water cement ratio result to decrease in a compressive strength of the concrete. Due to the silt content, we required extra water for the mixing, and it disturb the water cement ratio which is designed for the mix, and water cement ratio will directly affect on the strength and also with the on the workability of the concrete. So it disturbs the water cement ratio and also decreases the strength of the concrete. Second one is the increase in the sand fine content has also been found to decrease in the compressive and tensile strength of the concrete. That is, the silt content will decreases not only the compressive but also tensile strength of the concrete. So we have to avoid the sand with the maximum silt content on a site, or if there is a no no sand is available with a low silt content, then we have to use the available sand by washing it with water, and after washing we have to take a test, and if these tests shown the silt content below 5%, then only we can use this sand for the construction work. याच्यामध्ये जे आपण वाळू वापरतो त्याच्यामध्ये माती असेल किंवा सिल्ट असेल, फाईन पार्टिकल्स हे 5% पेक्षा जास्त असता कामा नये. तर त्याच्यापेक्षा जास्त असतील तर ते कॉन्क्रीटच्या स्ट्रेंथ वरती इफेक्ट करतात. शक्यतो साईटवरती आपण जी वाळू असते त्याचं सिल्ट कंटेंट काढल्यानंतर जर जास्त सिल्ट कंटेंट असेल तर आपण हे रिजेक्ट करतो. पण समजा एखादी साईट असेल आणि ज्या ठिकाणी आपल्याला अवेलेबल सँड यूज करायचे असेल किंवा पर्याय नसेल तर त्या ठिकाणी आपण ती सँड पूर्णपणे वॉश करून यूज करू शकतो. पण हे थोडंसं स्मॉल वर्कला प्रॅक्टिकली आहे, पण जर क्वांटिटी जास्त असेल तर थोडंसं अनप्रॅक्टिकल आहे. नेक्स्ट इज inadequate sand fine content also has adverse effect of strength on a concrete due to the over adhesion. The sand particle causes the poor bonding or the poor adhesion with the other ingredient, and it may shows the cracks in the concretes. Next, decrease in the slump value. That is the slump count test which will be used for the workability. As discussed in point number first, it affects on the water cement ratio and also the water cement ratio affect on the workability, and workability is measured by the slump cone test or slump value. That is, the silt content will affect on the slump value of the concrete. It is about the effect of silt on a concrete. If a natural sand is containing the large amount of a silt, then also it affect on plastering work. If we use the same sand for plastering work, then it show the poor bonding with the surface on which it is applied, or due to the silt content, there may be a finish which we obtain from the silt contained sand is not as per the clean sand. So we have to use the sand which is free from the silt and other impurities for mortar work, concrete work, and plaster work. And as per we discussed, the silt content is increases beyond the limit, then there is only single option to use the sand after washing with the water on a site. In a procedure, we adding the salt into the water so that it will separate the silt particles from the sand, so that they are easy to separate from the sand and come at the top. For this reason, we add the salt, common salt, into the solution or into the water for this experiment. Okay, hope you understand the silt content, its procedure, its determination formula, and its effect on the concrete properties. So it is about the silt content of a sand. In next lecture, we go for the another test, now fine aggregate, that is bulking of a sand, which include phenomenon of the bulking, effect of bulking, and determination of the bulking of a particular sand. Okay, thank you joining with us. Thank you very much.